Hi, my name is Enoch and welcome to In This Tech. In this video, we're going to be talking about Python programming skills, and we're going to be discussing some of the components build-ups in getting our hands very strong so that we can become skilled programmers and knowing how to use these foundational things in order to get jobs done. So once again, I welcome you to In This Tech, and my name is Enoch. So we are going to be talking about flow control statements, the if, the while, and the for statements. Generally, they are called loops, right? So we're going to talk about that in a bit. So we're going to be talking about comparison operators. We're going to be talking about Boolean operators, break and continue statements. And of course, as the saying goes, you don't know it except you do it. So we're going to write some codes for mastery, because if you don't do it, I can assure you, you would never know it. You would assume that you do know it, and there are many things there's something called muscle memory. Except you practice it, your muscles will start getting acquainted with it. So without wasting so much time, let's see. So this is a typical diagram that tries to explain what flow control statement is. So this is a chart that shows if you should go out when it's raining or not, right? So the statements, the program starts from here. So there's a condition here. Is it raining? Is raining? And then if yes, then the next condition comes. Do you have an umbrella? No, it says you should wait for a while. But if you have yes, it now says go outside. But if it's raining and it's no, is it raining? No, then you can go outside. But if it's raining, if it's yes, you don't have an umbrella, wait a while. While you are waiting, the question comes again. Is it still raining? Is it raining? Once it's a yes, it goes back, it directs you back to still wait a while. But if you can confirm if it's no longer raining and it's no longer raining, then you can go outside and the program comes. So there are many programs that you would want to write that would follow, that will have these many branches, where in order to be a lot more productive, you'd have to branch in different other places. And in order to get these questions, these conditions in a program, there's a way to depict or give the instructions to a computer in order to get it done, especially in Python programming. And that's exactly what we're going to be doing today. And in order to do that, there are certain operators that we ought to have ourselves well acquainted with. They are called comparison operators. They would help us put our conditions very well. So in order to give these conditions properly to Python in Python programming, then you would need to learn them. And of course, as you can see on your screen, equals, not equal to, less than, greater than, less than or equal to, greater than or equal to. These are the 6 comparison operators that we have in Python, and look at how they are represented when you're writing a Python code. Alright, next we'll talk about Boolean operators. Of course, there are 3 Boolean operators: or, and not. And I don't know, some of us that had acquainted with mathematics, logic, I think we should be able to be acquainted with this, but I think we'll try something here. So in the AND operator, it evaluates to false anytime the combination has a false, but except when it's the 2 conditions are true. So when it's true, you get a true. When it's true, false. Anytime it's with a false, it evaluates to false. So for instance, I could say 2 is greater than, okay, so 2 is greater than 2. If I should do that, and using the operator, you see, and it changes to an orange color because it's a function, is an inbuilt function in Python. 2 is greater than 2 and 2 is less than 2. Now these conditions are both false, right? If I should hit the enter button, it will evaluate to false. You can try any of these conditions. So let's try it for you. True. So true. In order to do this, I can just hit here. So true is equal to 2. True, remember this is how you represent equal to, and 2 is equal to 2. Once it's true, it evaluates to true. So in your convenience, you can try this other on your IDLE. You can just pause the video and try it out and see what it will give you. So you have the or. So this is the next, the OR truth table. The OR evaluates to true every time the combinations is true, or every time in the combination there is a true, except when the both conditions are false. So except this time they are false, whatever way it is, it will evaluate to true. And again, we'll try this for just two of them. You can try the rest in practice. So for instance, we want to do that 4 is greater than 2. Of course, that's true. And then we want to use the OR operator. And then we also want to say that 12 is less than 32. They are both true, so it evaluates to true. And if they are both false, that's when it evaluates to false. So 4 is less than 2 and 12 is greater than 32. So when they are both false, otherwise it's true. So you would want to confirm this by trying it out. And of course, you can even type this directly on your IDLE, and you will see true and false will give you a false, right? You could do this with the OR operator, and then it's evaluates to true. So you could try this anyways and get it done on your PC. So yeah, the not operator evaluates, just what it does basically, it just evaluates to the very opposite of it. So when you have the not operator, not true, so when I say maybe not true, of course, all right, the not is supposed to be, I had an indentation, so it's not supposed to be. So once I do this, it's false. So it just evaluates to the very opposite. So you could try the rest too again. So next, what are we going to be talking about? Let's continue fully and break and continue statements. Now these two statements are usually used when you're having a loop, when you're having a loop, like in order to keep, when you're doing something within especially when you're talking about conditional statements like if, for, and while. This is usually the context to which we use break statements and continue statements. Now this statement is used to break, for a break, and this, the bracket is how you write it on in Python, break with a small letter, or in small letters. This statement is used to break a program out of a loop without checking the condition again, so that anytime in a loop it gets to the break statement, it doesn't even check the condition anymore. It leaves the loop. It's like an automatic, it's like an emergency exit. Once we hit this exit, it just leaves the loop completely. For a continuous statement, what it does is that once we, when the progression of program, when the execution, of course, in Python, codes are executed line after line. So when the execution goes down and hits a continuous statement, when it hits a continuous statement within a loop, it doesn't continue because every time that you are writing a loop, it finishes the instructions within that loop, then goes to the conditions to check again. But when you have a continuous statement, as soon as it hits the continuous statement, it reverts back to the condition, regarding less every other lines of code that are beneath it. So once the continuous statement, this statement is used to make a loop jump back to the condition without completing the loop. It's like a recycle. As soon as it gets to the continuous, it hits it back and it goes back to the conditions. And of course, practically we are going to see it in a while. This is just basically to give us an idea of how it works. So quickly, we are going to start with the if statement, and we have a syntax here, and of course we are going to practice it. Even we have a project to do here. So the project is that we are going to validate a staff user in this step. We're going to validate a staff user. Of course, we'll just ask him a few questions, and if he's correct, we'll validate that. That's the project. All right. So okay. So all right. This is the syntax of the code. So let's open a new file. In the file, let's open a new file, and we'll try to see how the syntax goes. But in order to do that, let's just see Let's write a code. Let's write a quick code that will just, just show us how the syntax work. So for instance, let's print welcome to English Tech. Or okay, let's just do welcome to English Tech. And then let's ask the user to print their name. So please, all right. But of course, I could just need to write the print function. Print. Please enter your name. So once I do that, let's use the name variable to collect whatever the user is going to enter from the keyboard, and then let's use this. So this is the condition. So if they now ask us the condition, so if the name is Alice, of course this is equal, and since Alice is a string, we have to put it in with a quotation, and of course the input statement returns a string. So if the name up, then we'll now put a semicolon. Are you seeing the condition? So if, then the condition, then a semicolon. So if name is a condition, semicolon, then an indent is created. But let's just finish. So print hi Alice, hi Alice, um else print hello stranger. It's supposed to be a stranger. Now we'll run this code. So but what does this code say? So the output will show a print to welcome to indice to ask the user to please enter his or her name, and then this code would receive whatever it is the user inputs from the keyboard or from the keyboard of his PC. Then here the if statement comes. You see the syntax here. So if the name, these are the conditions that we have here, then we have a semicolon, then an indentation. Did you notice some sort of a line between the if and the line? So, and that happens here. Once you use the semicolon, an indentation is created. So a block of code is written within the indentation. So anytime you're having an indentation, this shows us that we are having a block of code. From this if and else, this is a block of code, this is a block of code, and we have a block of code anytime we have an indentation. So it says if name is Alice. Now what happens is this: once the condition is met, then the execution breaks into the block of code and executes whatever is in the code. If the condition is not true, it never breaks into the condition of the block of code. It jumps this block of code and continues the next line. It comes to the else, and this after this else, there's an indentation again to say that if this is not met, that means this should be met. Basically, that's what it means. Then this block of code is printed. This block of code is executed. So that's basically like the idea. So if we are to run this, of course we'd have to save it. So let's save it on our desktop as if statement. So right, let's just say on our desktop as if example. Okay, example.py. Of course we know that py is the file extension name for Python code. So let the output come out and let's see what works. So it comes here, said okay, enter your name, and I print Enoch. Once I typed Enoch, this was not the condition, so the condition was not met. The condition was this: that if his name, print hi Alice. If it's not met, print hello stranger. You see that's what's being printed out, hello stranger. Let's rerun this. Let's just press F5. and rerun this code. So what if I use Alice? Said hi Alice, right? So in order to understand this fully, let's consider a a flowchart. Now consider this flowchart and see what's going on here. So the program starts. This is the condition. Name is it Alice? If it's true, print hi Alice. Just like we tried to explain the other time from this, right? So if it's true, print hi Alice. Otherwise, if it's false, print hello stranger. So that's exactly what you see here. Then the program ends. So this is like the syntax of the if statement. And of course you can have multiple conditions. That's where we're going to talk about the if and the elif statement. So this is a condition for the if and elif statement. So let's imagine. So this is exactly the same thing you see here. So the condition, the once the column and indentation, then the line of code, if this condition is met. But you could have different other conditions. So else if this condition, right? So this is the elif, is like else if, right? So else if that condition is not met, how about try this condition, try this other condition. If this is not also met, try this other condition. And if all of them is not met, just print, just continue on this line, right? That's basically like the idea. And is also to note that in case these conditions happens to be true, it never continues, the program never continues to say, okay, let's how about let's try this. Once any condition is true, it breaks into the code, and that's it leaves the whole loop, it leaves the whole conditional statement and prints out. So let's try something. So let's assume also from this code that we are having multiple users in this tech, right? So let's say this was like a staff website, and for the staffs you have to put, you just enter your name. Once your name is open, it just say welcome, right? So let's just use the word welcome, welcome Alice, right? So let's assume that Alice is one of the staffs, and we have like maybe just 3 staffs, right? So and I want to write another, so I write if name is, say Enoch is another staff, so Enoch, if that is true, then print um welcome Enoch. And again I have another condition, say if name is equal to, let's use the founder of in this tech, Ahmed, that's his name. So if name is equal, if that, then if then print, if that condition is met, print welcome boss. So in this I've given multiple conditions to it. Let's see, sorry you are not a staff. So yeah, if we run this code, let's just press F5 and then run this code and see what happens once this code is run. And so notice exactly what, welcome to Indies Tech, please enter your name. And in case it's Enoch, I put Enoch. I have a condition for Enoch, it welcomes Enoch, right? It welcomes Enoch. Let's run it again and see. Let's run it again. So let's say for instance I use the CEO enters his name as Ahmad. How did we, all right, yeah, for this let's say Ahmad, say welcome boss. How about if any other person tries to log in, into the into the system and say his name is maybe Frank, sorry you are not a staff. That's basically what it checks the condition. And once it was Enoch, it didn't have to come back to check if or say any other thing. Every other conditions is neglected once any condition is true, and it continues in the line of the code. So that's basically how if statement is, and I think this helped us to write our project. Let's check our project again. evaluate a staff in this. I think we've run the project already by trying to explain it. So let's say these are the staffs and we validated the stuff. This is basically our project work, and I think we can go ahead from here. So what about the next statement, the while statement? Now the while statement basically it carries, it takes the same idea for the, it takes the same idea for the condition, for the way loops occur. However, in this what happens is that the line of code is checked, it continues when the condition is met. This basically the syntax, right? When the condition is met, this loop will not stop except this condition is false. So you see, for the if statement that we have here, once it's true, it breaks in and does this. But for the while statement, it will keep repeating the loop until the condition is false. And of course, if the condition was false in the very first place, it never breaks into the indentation to do this. So in order to do this, let's just, instead of, okay, let's just create a new file. Let's create a new file. Let's delete this. Let's create a new file, and let's run a code that prints hello world 5 times. Let's just use, because of the flowchart we have here, let's write that same code. And we'll have a project here to do, so we'll try to solve the project as we go ahead. So let's say print, of course you can name your distance for clarity using the hashtag, which is basically a sign for comment, and every comment is a non-executable line of code. So anytime I use a hashtag, it will make sure, it just helps me to understand what I'm saying. I can use that to comment, that's the word, but it doesn't execute that line of code. So let's just write while statement practice. Let's just leave it there. So let's just print again. Let's say we're just doing it. We'll always welcome it, our culture to always welcome people to our classes. So welcome to In This Tech. Alright, welcome to In This Tech. And then next we see, alright, so we want to print a code that writes hello world. So let's initialize a variable, because we want to use it in the condition. So let's say that, let's use a variable spam, just because of the flowchart we have next, just to understand it. This is an assignment variable. Now you see the difference between equals to and literally in the usage. This is an assignment operator. This one equal is assigning one to spam. So spam is the variable, is assigning one into the spam, so it's an assignment variable. But if I use double equals in this manner, it will mean that spam is equal to 1. This is no longer a variable, this become a condition. So this is an comparison operator, while this is an assignment operator. So yeah, so let's say that while spam is less than 5, of course, print hello world. Once I do that, then let's increase spam plus 1. Alright, so what will happen when we run this code? What will happen is this. So it initializes spam as 1, so you have a spam, because of course if you're bringing a condition in, the program should have understood what exactly is going on. Is this, what is this? So you have told him that this is a variable and it carries 1. So he checks the condition. What is spam here? Spam is 1, and is 1 less than 5 is true. Once this is true, it breaks into this code, this indentation. It breaks into the block and runs this. So it will print hello world. But before it goes back to the condition, there's another line to say that spam. What was spam? Spam was 1. So 1, okay, yeah, spam was 1. 1 plus 1 becomes 2. You have assigned spam a new variable to be 2. So it has increased. So we call this incrementation. We've increased the spam value. So once this is now 2, it goes back to the condition again, because while we'll keep going back, it will keep running this except this condition is false. Once it's 2, you say 2 is less than 5, that's correct, it will continue again. By the time it gets here, it has, because it was 2, it will now be 2 plus 1, it becomes 3. And again, it checks again. Is it less than 5? Yeah. It will keep checking this thing. But it now gets to 5. Is 5 less than 5? It's saying no, 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 no. Because it's no longer there, it stops. So maybe when it stops, say let's get an output that says print we have to stop here. Alright, we have to stop here. So let's run this code. Oh boy, what did I do? Alright, so let's run this code. I just did F5. So of course we have to save it. Let's save it in our desktop as let's just say spam.py. Just spam, just to help us run the code. So when this code runs, what goes on? Let's see. So you see what happens here. Hello world, hello world, hello world, hello world, 4 times, right? It says we have to stop here. Once it got to the end of this, you have to leave the loop. At this point, this condition is not true. It will go back to the next line, and of course it will go back to the original indentation. Is there anything here? We'll get it done. So that's basically like the idea. And someone will ask, but this thing is 5. We said it was less than 5. 1, 2, 3, 4. We didn't say it should stop at less or equal to 5. So if we want it to 5, we say less than or equal to 5. And once we run this again, I think it should come out with 5 outputs now. So you see 1, 2, 3, 4, 5. You see, that's basically what it is. So but in order to also have a graphic understanding of what this is, let's check the flowchart that describes it. So this is it. So it starts here. Is spam less than 5? If it's false, of course this flowchart doesn't have this, right? So if I delete it, it will end, right? Because it doesn't have it. But if it's true, it will break into the code. And what is in the code? Print hello world. Say okay, I will print it. Next is it increase spam by 1. Say okay, I've done it. But once it does that, it would not continue to the next line. It will go back to the code and say, is it true? It's almost to say as if you send it on an errand to confirm. Is this errand correct? Done properly? If it says not done properly, do it again, it runs again. If you say it's okay, then it breaks out. So that's basically like the idea of the spam, of the while statement. Okay, and we have a project here, and the project is that we write a program that solves the factorial of a number. But in order to do this, I think we'd still have to use this code. All right, let's just create a new code. Let's just say let's type, let's comment as factorial, say project 2.0 factorial. Alright, so let's just call it like that. So we have to understand, how does factorial work. So the formula for factorial is largely this. So we have factorial n, let's say n, any number will now be n into n minus 1 into n minus 2, and it continues like that, of course with a multiplication. So this is n multiplied by, alright, n multiplied by n minus 1 multiplied by n minus 2 multiplied by, it goes on like that till it gets to 1. This is a basic formula for factorial. So we want to code this, we want to automate, we want to create a calculator that solves factorials of numbers. Having this known, then I think we can try, right? So if we have int enter any number, because the project says any number, enter any number. All right, and enter any number. All right, so let's stop here, and then again, of course, we would ask it to, once it enters this, we want to call this val, right? That's a value. want to assign that whatever input the user puts in, let him store it for us as val. And once we have that, then let's say we have another one, this thing that says factor. Let's just code factorial to be factor, and then of course let's initialize it to be 1, since 1 is like the base. And of course there is something that is called identity in mathematics, such that any number multiplied by 1 is the same number, right? That's like an properties of some of that. So 1 is an identity value. If you multiply it by whatever identity, that retains its identity. So having known that, let's just have this. So let's use the syntax here. So we have the while, then we have the condition, semicolon, then we have our so let's use the function while what's the condition? Factor. Now while factor is less than 1, let's just say while factor is okay, while the number that the person puts, let's just use val. So while val is not equal to 1, let's use this, right? This is a condition. So we have while, then the condition, then the semicolon. So this is while. We have val here. We had assigned that whatever number the person puts, let him save it to us as val. So we have while val is not equal to 1, because the factorial of 1 is basically 1, right? So we will write a code for it, but while factorial, while the value is not equal to 1, okay, let's just make it write any number not equal to 1, because let's limit our calculator to that knowledge. So while factorize it, so what does he do? He should just do that factor. We'll try to implement the formula. That factor should be factor multiplied by val. So basically what we have here is like 1. We had initialized factor to be 1, and once factor is 1, okay, let's just finish the code, and of course let it be reducing val by 1. So we have a decrementation. In our example we had incrementation. Once there's, I think this should capture print factor. Now this should solve our problem, because you see, once the user puts any number and we have initialized factor to be 1, once that number is not equal to 1, it will break into this code and it will do factor. Here factor is already 1 times is that number the person puts, and of course that will give us n. Then we now reduced it to be n, reduce the n as it were, the val value, reduce the value by 1. So we reduce the value and checked again. Is the value still 1? The value is not 1. It now be like, okay, so n that factor, which is, what's the factor now? The factor is, will not take on the new value times that. So that, for instance, in order to understand this, let's make it graphic. So let's say 5 factorial. So if our 5 factorial should be equal to 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. So the thing is getting multiplied, but by the reduced number. So, and that's exactly what is going on here. That's what is going on. It's just reducing this value, is just reducing the value, and we go on. So if we do 5 factorial, this should be 5 times 4, 20, 20 times 3, 60, 60 times 2. So this should be 120. So, but let's run this. Let's run our calculator. Of course, okay, let's comment on this, otherwise it would want to run this. So let's comment on this, and yeah, we can run this. Of course, would have to save it as let's just save it as factorial .py. Alright, once this code runs, let's see how it looks like when it does. Oh, it's not getting full, so let me just, yes please, F5, and let's see. So the program has asked us, okay, we should enter a number not equal to 1. Okay, let's do 5, right? Alright, then there's an error here, and what's the error is that we remember the input function returns a string value. So I didn't tell him that I didn't tell the computer or the program that the function I want should be an integer value. Once I get that corrected, and I think it should now run. So let's try. So here it asks me to enter any number, so let's put 5. You see 120. Now in this case we had run this open, so if I should run this, let's say F5 again. I just hit my F5 button, and let's use any number. 6, the factorial of 6 is 720. So this calculator just keeps doing this. Any factorial you want, any number you want, it will run the factorial of it. Let's say 54 factorial. This is it. This is it. This is exactly what it is. So I think we've done our project, and we can continue with our video. So yeah, so now this is the loop statement. In the loop statement, all right, so in the loop statement, this is exactly what it is too. It's also, the syntax is, we'll have for, then we'll have a variable in range. Of course, please let's pay attention to this. A variable in range. Okay, so variable in range of, then another, then the condition, then you have the semicolon, you have an indentation, then you have the line of code. So this is basically okay, we have a project here too. So this carries the same idea. We've been talking about these loops for quite a while now, so it carries the same notion. And in order to get that done, let's open a new file editor. We can delete this, and we'll have this here. So let's just run our code, our project with this, and see how it goes. So the project says that we should write a code that sums even numbers from within any given range. So all right, so let's ask the user. Of course is a custom. We'll welcome the user. So in this text, and then again we have print. So let's say that all right, sorry. All right, let's say that we are going to be having, all right, I think we opened another one. Yeah, so let's say please enter, since we said any given range, we need to get the upper limit of the range and the lower limit of the range. So let's just use enter the lower limit of the range. Enter the lower limit of the range. Okay, and whatever the user should enter, let's write it as lower LW. Let's save it as the input. Of course is an integer, since you're talking about the range. It should give us within an integer. Then we ask the user again to please enter the upper limit of the range, and let's say up as upper. Of course it's an integer, so since this was gonna normally return a string value. So once we've been able to establish what's the upper limit and the lower limit of the range, then I think that we should also have a variable. Let's use the variable sum, and let's say sum should be, let's initialize sum as 0. Sum as 0. Well, sum is a function, so let's just use word cal, right? So cal equals 0. So we're going to use the for loop now. What is for loop? For loop continues to, like we also said, it enters if the condition is true, so if this condition is true, it will break into this line, this block of code, or these lines of code. And once that is done, what happens is that it begins to it's used for making a program to repeat itself for a given number of time. So on while statements, what it does is that it does a code repeatedly until the condition is false, right? Until the condition is no longer met, it will keep repeating the program. It's basically called iteration, to keep doing it over and over again. If basically what if does basically is that if checks this conditions, once is correct, it breaks in and carries it out. But for it will do it within a specific range, within a specific time or limit or boundary, right? That you would put for it. So in order to call the function, so we have for let's say variable I, for I in range. See the syntax, I'm still using it for variable in range. Then you have the condition. So again, you see we said that the condition, the limit should be is determined by the user. So of course the lower limits, so we saved it as LW, and of course in range we separate it by a comma, and just the way we are writing it out now, range then upper limit. Okay, they said even numbers. All right, so in order to understand even numbers, again we need to understand how is even numbers, how do we get even numbers. Logically, even numbers are numbers that can be divided by itself, by its two, without having a remainder. So take for instance, you have any number you can divide by 2 without having a remainder is an even number. That's the general definition of even numbers that we have. And one easy way to get is that is in the multiples of 2. That means after every 2 steps, you get an even number in the order of numbers. So for instance, let me comment on this and have 1. All right, so let's say we have 1 comma 2. Okay, 1, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. How do we get even numbers? After every second step. So after from 2, counting after 2, 1, 2, the second will be an even number, 1, 2, the second will be an even number, 1, 2. So that's basically the idea, the trick we're going to use for solving this. So in order to do this, we know that we can add another step. All right, so somebody may be asking, what is this step that you are adding? When you want to run a code, when you're defining a range function, you have the lower limit and the upper limit. If you have another third variable, if you have another third what will I call it now? If you have another third item within the range, is basically the steps. It means the number of steps it will take between these two range, and between these two, yes, range or sets of values, the number of times it should take. So after 2 steps, it's called step value. It's usually the step value. So of course we put the semicolon just like we saw here. Let me make it a lot more elaborate. So we have this, yeah. So once this is done, then we ask it to, if this condition is true, what does it do? We should sum it. So we have sum, we are okay, cal, we use it as cal should be equal to cal. Of course we had initialized cal to be 0, so cal should be cal plus this I. This is a variable now, right? This variable. And once this code is done, once it's done doing this within this specific range, let's ask it to print cal for us, which happens to be the sum of this. So of course, if we are going to sum, let's still check if the even numbers here should be 2, 4. All right, okay, let's do it plus 2 plus 4 plus 6 plus 6 plus 8 plus, all right, we're going to see something here. So this is the range, say between 2 and 10. Okay, so just to save time, here you see that it didn't get to 10 because this upper limit is usually not counted. It's usually not counted. It just defines the range, but it's usually not included in Python. That's how Python works. So if we want to include it so that our calculator will be a lot more accurate, then would have to add one, to just increment it by one, having known that it will not count particularly with the limit of the boundary. It doesn't calculate with the limit in view. So in order to do that, then I think I should get maybe another variable. Let's call j, or yeah, let me just call it j. Let me ask j to be up plus 1, so that this would help me make it more robust. And instead of having the upper limit here, I want to have it as j, so that I can include the very limit in the calculation. I can include the very limit in the calculations. We're going to do something just to check it. Let's save this as, let's say, what's this? Okay, even numbers, even sum. Let's just do even sum.py. Right. So once we save this, let the code run. Once it's running, let's see how it's going to. So let's say it said we should enter the lower limit of the range. So let's say the lower limit is 1. Okay, let's say 1, and the upper limit is 10. You see it's having 25 here because it's having 25 here. Why? Because we said it should start from 1 to 10. The number should be 1, should be, what's it called, it should be within 2 plus 4 plus 6 plus 8. Okay, we added 10, right? It should be plus 10. Why is it giving us 25? Because if we add this is 2 plus 4 is 6 plus 6, 12, 12 plus 8 is 20, 20 it should give us 30. I think it's because we said that the lower limit should start from 1, and once it's starting from 1, it will start its movement from here. So if it starts its movement from here, it's going to be 3. So let's see again. Let's run the calculation together in the way we wrote the program. This is also to show that the computer will just keep doing what you ask it to do. So if we have 3, because it wouldn't count, okay, it wouldn't count from that limit, so it will start from 2. So we have 2 plus, it will now move 2 steps from 2, 1, 2 plus 4. All right, okay, 1, it will move 2 steps, so we have 3 plus 5 plus 7 plus 7 plus 9. So if we were to do this, this is 8, right? If this is 8 plus 7 is 15, 15 plus 4, 15 plus 9 is 25, 15 plus 9 is 24, it's 24. So what happened here? All right, why don't we reduce, since we know that the lower limit is usually starting from, it's not including that limit. So why don't we just have a limit within. All right, let's try something. All right, okay, yeah, so we are trying to evaluate what's going on here. So we said that so the program is going to start from 1. So what it will do is that it will do 1 plus, it will now move from here to the second one. From here, it will start from here, having 1 at its first, 1, 2, it will start from 3, which will violate the conditions that we have for it. So in order to get even numbers, it would either tell the lower limit to always be 0, but our project says that it should be any given range. So let the user be the one that determines the range of the value, right? So in order to do that, knowing the way Python works, we had to add 1 to it so that it will include the range from here, and then we also need to allow it to start counting from 0. We need to allow it to start counting from the number before the lower limit. So just like we incremented one, I think we should also let's say k j, let's, can we use another value, say m lm, right? Lower limit, let's just use lm as the lower limit, and the lower limit should be the lower limit, that the lower width, let's just use lower of the user minus 1, and then this, let's just call this um ul, upper limit, right? So we'll now be having lower limit and then upper limit in increments of 2. The idea we are trying to run here is so that we don't have these kinds of errors, because like we saw in this program, what happened was this: is when we have 1 here, it becomes 25, right? The answer becomes 25. But this violates exactly what we are trying to do. We need it to ensure that the lower limit starts counting from exactly that lower limit, knowing the way range. Okay, let's see something. Let's ask, let's use the length function of 1 comma 10. Will this run? This is not supposed to. I'm supposed to give it like all right, let's say, let me do this. So let's define Enoch. All right, let's just say um class class this class is having this range between 1 comma 10, right? Okay, class is a function. I need to use another value, another variable. Let's say clan. All right, so clan should not be a function. And if I were to do that, I would have what if I want to access the length of clan? I don't know if I can do that. We're all learning, so let's see. It shows me that the length, it doesn't give me the range. Doesn't bring the idea I wanted to pass. But the idea I wanted to pass was this: is that you see, the range of a function brings out the values. I would have used the dictionary, but it would take me a lot of time, and we don't have that now. So it brings out the value. We want it to start counting exactly from the lower limit and the upper limit. And in order to do that, we need to go one step backward so that it will start counting from exactly the value, and one step forward so that it will end exactly at this. That's the reason for all of this. So if we run this code ideally now, let's see what comes up. If we run this code ideally, let's enter the first range, the upper limit as 1, and it brings 30, which was the original. Of course, if we do this, it will give us 32 plus 4 like we did earlier. It gives us, and it brings a lot more robust or accurate perspective. um so if I should run this lower limit and of the range, so let's use another lower limit, 25 and 50. This is an accurate number of um of a calculator that sums even number using a for loop. So that's like the idea for a for loop. I think we're done with this project, and we have an overall project to carry out, and this would help us incorporate these statements called the break and the continue statements. We had not used it. So in this project, it asks us to write a more robust validation code with break and continue statements. Quickly, let's just run that. Okay, let's open a new file, and let's run this and see how it works. All right, so quickly, print, all right, welcome to in this. So in this, we're going to make a few assumptions, and we're going to assume that we are having all right, let's see. Let's assume that we're just going to write a simple password checker, but it has break and continue statements. So in order to do that, let's say print welcome to in this tech, and while, let's say, of course, this is a while. All right, All right, okay. While true. Okay, let's assume, since it's a more robust one, um this is for staffs only. Let's just use this is for staffs only. And while this is true, if this is true, and of course it's true, while it's true, we're using the while statement. Print please enter your username. Please enter your username, and once the username is being entered, let's save the username as name. Okay, let's use user, and let's assume the user to be an input, and of course the username is a string variable. So when I want to write another condition, if user, using the syntax we had, if user is equal to Enoch, if user is equal to Enoch, if user is equal to Enoch, or let's say if user is not equal to Enoch, just a password checker for time's sake, just a password checker that just permits Enoch, right? So if user is not equal to Enoch, let's say continue. Now we'll get to see what this is. But if user is equal to Enoch, then print welcome Enoch. Please provide your password. Okay, your password, right? Please provide your password, and whatever the password is, let's call it code. Let's just call it code as password, and of course input. Then we have another condition. If the password, if the code, again another if statement, if the code is equal to, let's say that the password is Enoch 2024, Enoch 2024, right? If that's the password, of course with a semicolon. If the password is correct, break. This is just basically trying to use the continue and the break statement. Otherwise, if it's not the password, if it's the password, do that break. But if it's not the, and what you break out into is what you break. Okay, break. I can still use break. Let's say print access granted, right? Access granted. So, but if it's not password, it would if it's not password, it would let's can we have an else statement? Yeah, I think we can have an else statement here. Print wrong password. I think this code should run, as at least it has the continue and the break statement, and I think it's a little bit more robust than the other one that we did. So what happens here is, while true, once the user, of course this is true, this is for staffs only. If you have gotten here, it means you're a staff, and that is true. And if it is true, print enter your username and it collect it as user. If the user is not Enoch, this continue statement will go back to the condition, and of course the condition is true, that is for staffs only. It will still ask you to print your user. All right, let's just run this, right? And let's save it as final project before we call it a day, right? Final project.py. All right, let's save it as final project, and then let's run the code and see. Okay, yeah, this is an assignment variable, so sorry for that. I think it should work now. So welcome to In This Tech. This is for staff only. So if you have gotten it for staff, and that's true, because it's true, it ran into the code to say print your username. And say for instance I used user alright, let's say the username is I use tech. Let me print my username. Do you notice what's going on here? Because once is not Enoch, it cannot break. Once it's not Enoch, I told it, if it's not Enoch, it's true. There's no, it will go to continue. The continue statement goes back to the condition, and the condition is true, so it continues this code. It will keep doing this until you write the actual code. If I write user, it will still ask me to print username. So in order to do that, I know that the username is Enoch, and it goes on. Because the username is Enoch, it goes on to say that I can. Yes, so because the username is Enoch, it goes on to say that I can enter the password. So it's breaking into this code. Please enter your password. Say I wrote another password that is wrong. Okay, the password is, I told it next code is, if Enoch is, if the code, so you save it as code, if the code is Enoch 2024, it will break. So let's just, for time's sake, let's just Enoch 2024. It goes back to wrong password, so I have to go back to the username again. So let's have Enoch, then I have Enoch 2024, access granted. So once it hits is true, it will break, and this break means leave this loop. It doesn't even matter what's next below, it just is an emergency exit, like we talked about. Emergently or immediately evacuates. It leaves this entire loop and then goes back to the original indentation to print access granted. So this is more robust, and I think we can call it a day. Thank you so much, and see you next time.